going to talk about congruence in right triangles. We have a special theorem that we're going to use when we're trying to prove right triangles are congruent, and it's called the HL theorem. So, when we have right triangles, we have parts of right triangles. We have legs, which are the two shorter sides, and we have a hypotenuse, which is a longer side. And we also have a right angle somewhere that connects the legs, okay? Now, it does not have, it's opposite the hypotenuse, okay? So it has no connection to the hypotenuse other than its opposite, okay? And our hypotenuse leg theorem says if the hypotenuse and a leg of one right triangle, and let's draw in my little right triangle squares here, are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So I have a hypotenuse is congruent to a hypotenuse, and a leg is congruent to a leg, then the triangles are congruent. And this really makes a lot of sense if you consider that we have the Pythagorean theorem that we can use to prove this, okay? And because they're right triangles, okay? So we can use the Pythagorean theorem to prove this, and we could probably use a couple of other different ways to prove this too, but the one that's most straightforward is to show you with the Pythagorean theorem, because of course we have a squared plus b squared equals c squared, right? So if I have a squared plus b squared equals c squared, then b squared is going to equal c squared minus a squared, right? Now, if, we'll call this D, E, and F, okay, if we know that F is equal to, F is equal to C, then F squared is equal to C squared. If we know that D is equal to A, then we know that A squared is equal to D squared. So that means B squared is equal to F squared minus A squared, and B is equal to the square root of F squared minus A squared. Okay? Now, we also know that D squared plus E squared should equal F squared, right? And I'm going to move this around a little bit so I have more room. That means E squared equals F squared minus D squared. Well, I should have written a D here. It's supposed to be a D squared. And E equals the square root of F squared minus D squared. And what do you know? B equals the square root of F squared minus D squared from up here, right? So therefore, B equals E, and that length, that means that the side B is congruent to the side E, okay? So, that goes to show that we now have side, side, side. All our sides are congruent to all our corresponding other sides, and so that proves our hypotenuse leg theorem. You don't need to memorize this, I just thought you'd like to see it. Okay, so using the hypotenuse leg theorem, we need three conditions to be met. First, we need to show there are two right triangles, that they have congruent hypotenuses, and that there is one pair of congruent corresponding legs. Okay? If we can show that, then we have two congruent triangles, right triangles. So let's look at this. Here we are given that BD is the perpendicular bisector of AC. So BD is the perpendicular bisector of AC. And ABCD is a regular quadrilateral. And we want you to prove that all four of the inner triangles are congruent. Now, of course, this probably makes sense to you as you look at it and as you think about it, but hey, we can prove this as well. So, let's write this down. We have our statement. And we have our reason. So, we are given that ABCD is a regular triangle. Not not triangle, quadrilateral. Just call it a regular polygon. And that's a given. That means that all our side lengths are the same. So therefore, AB is congruent to BC, which is also congruent to CD, which is also congruent to DA, right? So that is by definition of regular polygon. Okay? Now, we also know that BD is a perpendicular bisector of AC. So BD is the perpendicular bisector of AC. And that's a given. So since BD bisects AC, that means that AE is congruent to EC. And that's by definition of bisector. This also means that angle BAE and angle BEC and angle DEA and angle DEC are all congruent and they equal 90 degrees. Okay, and that is definition of perpendicular. Okay, so all those angles equal 90 degrees. Okay, so now we have a hypotenuse and a congruent leg and a right triangle in all four of those triangles. Okay, and so by the definition, by the HL theorem, not definition, triangle BAE is congruent to triangle BEC, which is also congruent to triangle DEA, which is congruent to triangle DEC. And we've proven all four are congruent. So what we've learned the hypotenuse leg theorem applies to right triangles, and using our three conditions, we can prove that right triangles are congruent to each other. See you tomorrow.